Hello, my name is Lauren Berg, and today I will be presenting my examination of the weather data for the months of February and March 2019 for the locations of Bethel and Kuparuk, Alaska, as well as the general climate comparison for both locations. Here is a map of Alaska and the nearby water masses to show the general area of both locations. I will go more in depth about how these locations influence the temperature and humidity later, but for now, note how both locations are in maritime areas of influence near bodies of water, and how both areas are cut off from the interior area of the state in continental climates as a result due to nearby mountainous terrain. Kuparuk is at a much higher latitude than Bethel. However, both locations reside within what could be considered an Arctic area, due to Alaska's general location far in the northern latitudes. Here we have temperature, pressure, and humidity readings for the month of February in both locations. As you can see, both areas had a fair departure in temperatures from the average climate temperatures observed in Bethel and Kuparuk, as noted by the gray, mostly flat lines near the bottom of both temperature graphs, here and here. The range for Bethel is only about 10 degrees in terms of its general climate, with an average area around 9 degrees Fahrenheit. However, the observed temperatures of the weather station PABE showed a drastically higher temperature at an average of 20 degrees higher, centered around 30 degrees Fahrenheit above zero. This change could be due to several factors, but the most explainable will be that of a change in air mass from a lower latitude region. This is because of the recorded dew point, as you can see down here and down here. The dew point and humidity shift rapidly at the start of the month, as noted here, rising to a level to meet the recorded temperatures. This shows a change in the general air mass, denoted by the water content of said air mass changing, that may have raised the temperatures significantly, as opposed to a diurnal shift that would be evident in many hills and troughs between highs and lows depending on the day of the week, which aren't visibly consistent on either the temperature or humidity reports. The same can be said for Kuparuk, which, while having a much more variable temperature than Bethel, as you can see in this trough here, and this large peak here, and sort of over here, it still shows a range of humidity, it still shows a change in humidity that insists of a changing air mass, as you can see down in this graph here. Even the pressure of the area, as you can see by this green line here, it shows a change in the air pressure that denotes a change in the air mass in the column of air above Kuparuk. This change may be much more variable due to the multiple air masses passing through the area due to storms or fronts, as I will note later, compared to Bethel, which only shows signs of one major air mass advection throughout that week that is denoted by this sort of consistent line here. Overall, the change in temperature from the climatological average was much higher than normal in both areas. Here we have the temperature, pressure, and humidity readings for the month of March in both locations. As you can see, the data has a much different look from that of February, with many hills and troughs in Bethel, and a similar appearance to that of the previous month in Kuparuk. For Bethel, this appearance of many hills and troughs between days, as evidenced by the high temperature during the middle of the day, which you can see here, 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 is separated with a lower temperature on both sides. This is characteristic of a diurnal cycle, where nighttime temperatures drop from daytime temperatures just after noon. However, taking the averages of these hills and troughs, there is a notable downward trend in the beginning of the week, as noted here, and an upward trend at the end, which is supported by the humidity readings as well, which you can notice here and here. This shows a marked transition between two different air masses, which somewhat keep this diurnal cycle but modify it by raising or lowering the average temperature in which the diurnal cycle functions. In Kuparuk, we do not see as much of this diurnal cycle, and more of a similar air mass modification as the previous month of February. As you can see, there is a clear change in humidity of the area, as well as a pressure change that mirrors that of the temperature change, with low pressure during warm days and high pressure during cold days, which may signify changes in cloud cover that lead to more IR radiation leaving the atmosphere due to a lower cloud cover. Here are some general weather maps to give you an idea how this change in temperature from day to day can be influenced by these air masses. As you can see, there are clear lows, highs, and fronts that influence the pressure and general temperature of the area, especially in the realm of cloud cover, which greatly impacts the amount of solar radiation and IR loss throughout the day and night. These storm systems are also influenced by the mountains that are close to both of these areas, which kind of keeps out certain weather formations. Another major player in the changing weather could be caused by the jet stream, as noted by upper air charts of the 300 millibar level. As you can see in 2012, here, there was a generally segregated air mass over the entire state, as denoted by this area of purple and blue low height having a clear straight line between it and that of the yellow and green of higher height at the lower latitudes. This causes the tropical warm air of the lower latitudes to not circulate as easily into the state, keeping the Arctic air mass and the warm air mass from mixing, and keeping the temperatures from shifting from climate averages. However, in February and March of 2019, there is a noticeable hill or trough, depending on how you look at it, in this jet stream line, as you can see here and here. As you can see, the warm southern air mass is able to move inwards into this lower height 300 millibar area over the state, and then over the eastern part of the state in Canada in March later in the year. This influences the flow capability of the warmer southern air into Alaska and Canada, letting the warm air masses travel over the area and creating a warming effect. This effect slowly tracked east throughout the state, leading to the more air mass dependent temperature changes we observed in Kuparuk and the return of the more diurnal temperature ranges in Bethel in the month of March. Returning to the map of Alaska, we will now discuss some features that cause the climate of Bethel and Kuparuk, and how these features can impact the weather month to month in these areas due to things like global warming. As mentioned earlier, both Bethel and Kuparuk are under a maritime influence. This means that temperatures often have a low variability due to water absorbing and modifying the temperature derived from solar radiation, as compared to soil having a low modification of solar radiation and a greater effect of IR radiation. However, an important factor to note is the influence of sea ice on this process. The sea ice around Alaska throughout the winter and spring months changes greatly over the course of the year, starting with engulfing the northern part of the Arctic Ocean up here, and then reaching down to the island chain located down here throughout the winter and spring over time. This means that in Kuparuk, the effect of the maritime climate is much less visible than in Bethel throughout the year, because the sea ice covers the ocean and the high albedo of the ice reduces the amount of solar radiation absorption and further IR radiation in the northern part of Alaska around Kuparuk. This means that Kuparuk is more akin to a continental climate during the winter, and subsequently in months like February and March where the sea ice is still kind of growing out and not receding, leading to lower, more variable temperatures, whereas Bethel is less impacted by sea ice throughout the year. This can be changed, however, by the gradual warming of the ocean and earth in general due to global warming, which would reduce sea ice cover and gradually warm Bethel slightly over time and Kuparuk greatly over time. The reason Kuparuk is greatly impacted compared to Bethel is the exponential increase in temperature that results from the melting of even just a little bit of sea ice. It goes as follows. As sea ice melts, the ocean is able to absorb solar radiation. This radiation warms the area more and reduces the variability of temperature, leading to more warm days on average and less bitterly cold days in which sea ice forms. A lack of sea ice formation then follows, along with more energy and thus more warmth reaching the ocean. The less sea ice can form in general due to the lack of low temperatures is thus observed. And then, ice continues to recede and water continues to warm over time. Thus, Kuparuk would be much more highly impacted by global warming, especially in conjunction with shifting jet stream troughs and air mass advection. Thank you for listening.